All right. Good afternoon. This is the afternoon session. We start to get a little sleepy. There's going to be a coffee break later. We can get a little fix there. Today's session being led by Andrzej Poblocki, the globalization architect at Salesforce, and will be talking to us about service-oriented architecture with internationalization. Thank you.
Thank you for the introduction. And yes, I will be talking about how we extended internationalization, formatting, and parsing capabilities with the Salesforce i18n-Service-Library, or actually suite of libraries. But before I start, I would like to thank to the team that was working on this solution, and especially to the ones that couldn't attend the conference because of the COVID, because of the travel restrictions. So I would like to shout thank you to Yutaka, Mano, Yoshi, and Gonzalo, and also to all the contributors from the Salesforce globalization team and from Salesforce Lightning Web Component teams. Few words about me. My name is Andrzej Poblocki, but using Andrew is much simpler and easier for everyone, including me. I currently live in Texas, but I'm from Poland. And as you can see, there is some resemblance of the Texas flag and the Polish flag. And some fun fact about me is that I used to play a bass guitar in the punk rock band. Now, this is the agenda. I will show the path that took us to the i18n service. It's not always straightforward. That's why we have the curvy line here. We'll go through the requirements. We'll go through the planning, RFP, implementation, and current and next plans. So let's start with the beginning, requirements and challenges. So what we needed, and I grouped this into three categories. We had Salesforce users that required more responsive interface, and they required consistent formatting and parsing. Our application is complicated. Some of the stuff is coming from the backend, some of the stuff is coming from the front end. So regardless of the situation, we wanted them to see the same formats. And for Salesforce developers, as you can guess, this is the big community. So we wanted to give them easy to use i18n library that adheres to the best practices and standards. And we wanted to give them the API that will be the same regardless if they are using it on or off the Salesforce platform. And part of it, this solution will be available as the open source. So it will be available not only for Salesforce developers, but they can use it regardless. And we wanted to help with the adoption, with the usage of the solution, providing the linters that will guide them when they are in their environment, when they are developing the code. And finally, from the infrastructure perspective, we wanted to decouple front-end from back-end, and we wanted to reduce the number of calls related to the formatting or parsing that are coming from the front-end to back-end. So we put this in the 5 requirements, and we started with trust and consistency. Trust is #1 value at Salesforce. That's why we started with trust. We wanted to have the portability. We wanted to have the ease of maintenance. We want to follow standards and best practices. And we wanted it to be lightweight client-side library. So let me talk a bit more about this last requirements for lightweight client-side library. We had legacy framework that is more on the, I would say, JSP way of doing things. So there was JavaScript client, but for each formatting action, it was doing the call to the server. The same with the parsing action. So it was heavy using the backend, doing lots of call. We wanted to transition it to something more modern, something that runs completely in the browser, and that is only using the server for whatever is really necessary. So in our case, those would be the patterns. Now, there are options, and we explored those before starting our own development. So Int'l was the obvious choice, but it has some limitations. Some of those limitations are there no more, and some of those are things that that Unicode, that the task force is working on. But it's not supporting parsers. At the time when we were preparing for this development, it lacks the support for relative time format in some of the browsers. It didn't support and it doesn't support still the patterns, ICU patterns. You have the options object that you need to use. And it didn't expose the version about the CLDR version that was used. And in our case, for the consistency's sake, we wanted to be consistent with the CLDR version that was used in the backend. The other other library that we looked at was Moment.js, well-known and useful. However, it was too large, too heavy for our needs. We didn't need everything that it offered, and it was really lots of the download and functionality there. So what we decided to do is to use Int'l wherever possible. We wanted to create our own lightweight parsers. We wanted to extract the data from CLDR and to kind of establish local defaults. And we wanted to have the option to convert ICU formatting patterns to JavaScript Int'l options object. Now, next was the planning and RFP, so I will talk a few words about those steps. We separated into the couple of the modules, so i18n-Service-Library. This was to translate the ICU patterns into Int'l options object, and formatters. For formatters, we wanted to expose Int'l object format getter function. And we wanted to have the caching there. So we wanted to be kind of optimal there. So this object was cached. And after the first use, it would be reused. And the API signature was identical as the Int'l object. And for parsers, we just wanted to expose the parse method that is capable of converting strings into date and number objects. Other thing that we needed to develop is i18n's code module. And why we needed this? This was required for this compatibility on and off Salesforce platform. Salesforce itself exposed some of those properties based on the user profile. So if somebody was developing off platform, we wanted them to have the access to the same set of the properties. So this is for English, but it's the same for French and for Japanese and for other languages that we support. Now, we needed to go through the process of request for comments. And this is because our primary use case is with Lightning Web Components, which is our Salesforce web component framework. It is open source. And those changes that we are doing were considered as significant enough to require this entire process. So it was not only kind of proposed and implemented by globalization team, but this was also reviewed with the broader community of web developers at Salesforce and outside of Salesforce. For the implementation, I will talk about the scope module first. We'll go through the CLDR option module. i18n-Service, which offers the parsing and formatting. And I will talk a bit about the ESLint rules. So the scope module, as I mentioned before, we wanted those internationalization properties for every locale in the format that we use on the Salesforce platform. And what we did is simply repackaging the data that we extracted from CLDR in the format that was expected by the other packages. So it's the directory structure with folder names like ENUS, FRFR, and so on. And then each JavaScript is exporting some data. The next part was CLDR options. So we wanted to have the ability to use the CLDR patterns in JavaScript. And we are using ICU in the backend, so this was kind of obvious for us to pass this information from backend to frontend and then convert it to something that can be understood by JavaScript. So again, we repackage and we parse the formats and convert them to Int'l options object. And we expose those common formats as those objects, like short datetime format, short medium date format, and so on. And the last part is the service library that simply exposes those formatting and parsing capabilities. So it really, for formatting, it abstracts and cache browser's Int'l API, and for parsing, it uses our implementation. So how it works, those are the APIs, and those are kind of common things that you would use: get datetime format, get number format, get relative time format. And how it's used, it's imported from the i18n-Service npm package. You can override some of the options, and you can use it for parsing. So in this example, we have 123,457 yens. With another example with relative time formatting, again, we import the function from Salesforce i18n-Service. We provide some formatting options, and in this case, in English, it converts -1 day to yesterday. Now, the more tricky part for us was the parsing, where we wanted to use the patterns, and it wasn't readily available for us in Int'l. So we have the number parsing, date time parsing, and something that it may be specific to us, but I think is still useful, is ISO 8601 parsing. So it's not really related to specific locale, but it's still useful to convert this locale invariant datetime format, the datetime string. So let's start with numbers and with currencies. So we can provide this pattern. In this example, we provide the decimal separator and thousand separator in the format that we expect, and then parse the text. It returns the number object. It also supports the currency, so you can specify where the currency symbol will be, and again, it will convert it to the number. We didn't use any custom objects like currency, just the number, but the parser needed to know where the symbol will be. Datetime parsing, similarly, we use the formats, and we have the method to get the parser from a specific format. So the format is something that we get from the backend usually. And this is ICU format skeleton. So we can run the parser, and as no time was specified in this first example, it will go to the midnight in the local time. For ISO daytime strings, we have, again, the parser that understands the string with the time and also with the time zone. So in this example, we have the Zulu time zone, which is UTC time zone, and the strings convert correctly to the and is placed in the UTC time zone. As I mentioned before, we also wanted to help with the adoption, and what we thought is the best way to encourage people to do this is to provide some rules that will either highlight incorrect usages, highlight where they import the library that we don't want to use. And if this can be done in the IDE, it's even better, because those issues will be fixed before they even check in the code to the source repository. And in web components world, in JavaScript world, ESLint is most popular linter right now. So this is exactly what we did. And from our perspective, from internationalization perspective, it was even easier for us because this setup was done already for other Lightning Web Components related rules. So we just extended this. We added 3 rules that guide developers towards using this, using our library, and at this moment, those rules are not enforced, so it is giving them warning, but we have the option to modify this. And it discourages people from using, for example, Moment, because we didn't want them to use Moment. It discourages them from using our legacy methods that were doing those server calls. So what's the current state? For Salesforce users, we have the better responsiveness because we reduced those server calls. But because ultimately we decided to use the Int'l for formatting in all places, there may be slight differences in formatting, whether it comes from the server, which is using the ICU4J, or from the browser. But we figured out that this is something that will not affect our customers as much. They will still be able to understand it, and it won't kind of throw them off when they are doing day-to-day work. But we have exact same behavior for parsers between server and client. So parsers are using formats, and we thought that this is more important. Like if person has 2 input boxes and one would be served by server, the other by client, and they would work differently, this would be much bigger problem than with the formatting. For Salesforce developers, we gave them the modern standards-based library. They can use the same API regardless if they are on and off Salesforce platform. But again, this is tied to our Lightning Web Components. So this is our main use case. And Lightning Web Components is open source. You can use it to create your own web application. You can use it off platform, but in the Salesforce world, or you can use it within Salesforce with the Salesforce platform. The one addition is this ISO 8601 parser, which again was requirement for us, but I think lots of people may find it useful. We have the control over CLDR version because we generate those files from the specific CLDR version. And we gave them those ESLint rules that will allow us to see where the problems are and will allow them to react to the problems as they create a new UI or as they validate their PR wherever they want to use those rules. And from the infrastructure perspective, we not only reduce the number of calls related to internationalization, but we allow the backend to deprecate those APIs because they won't be used anymore at some point. And with us creating those parsers, we have smaller bundles comparing to if we use Moment.js for parsing or any other third-party library. So the last part of this road is what is actually in the process right now. It's open sourcing. So we, as the Salesforce, are giving back to the community. So this library will be available on GitHub in our Salesforce organization, and it will be distributed. The packages will be distributed on the open source NPM. The one package that I listed here is actually the one legacy one that hasn't been updated yet, but it exposes those i18n properties for English only. So right now it's still a stub. And that's pretty much it. Thank you guys for listening. Let me know if you have any questions.
Can you keep the slide on the links while we ask questions?
Excuse me?
Go back one slide to the links while we ask questions.
This one?
Perfect. Thank you.
Okay.
Questions?
Please go ahead.
So I'm interested in your conversion of the ICU patterns into the Int'l options objects.
Mm-hmm.
Is that done at runtime, or is that something that's packaged in those files?
Honestly, I would need to get back to the to the people who developed it, and I think we have both options available,
Okay.
but I will need to double confirm with the team. So lots of the things we repackage and made it available, but the runtime should also be able to convert those patterns.
Okay.
You mentioned one of the benefits was a reduction in size on the client. Do you have any rough numbers you can share?
I was telling about reduction if we use Moment, for example, which is about half a megabyte. So this one is, I think, slightly over 50 kilobytes.
10x.
All right.
Yeah.
And the decision to use the Int'l API instead of something like Moment, which I guess was already being used, right?
Yes, we used Moment before.
Was that primarily because of the size to move from that huge Moment?
Size was one of the considerations. The speed was the other consideration. But I think the biggest motivator was that we were actually in the phase of switching from, say, legacy framework that was using those server-side objects for processing to something modern. And the team who was architecting the Lightning Web Components wanted to use whatever is new, shiny, and good. And actually we did the testing and it was more performant, and so generally, I think nowadays it's really not recommended to bring the Moment because you have lots of this functionality in the browser itself. Please go ahead.
For the ESLint plugin, what are the different kind of rows that you are checking so that, in the PR stage?
Excuse me, what are the rules there?
Yeah, so in the ESLint plugin, what are the different patterns or rules you are checking?
So I don't have the examples here, but we check for 3 patterns. One is the import of moment library, because this will, it won't highlight all the usages of moment, but it will tell you don't use it, and will enforce to use the different methods. We highlight the use of our previous call, kind of wrapper. It's Aura localization service. So we highlight $A, which is Aura localization service. And the last thing that we highlight is direct calls to Int'l. So because we have this wrapper that supports caching, if somebody is using Int'l directly, then we highlight it. All those rules are configurable, so we can disable it. And I would say this, telling people not to use Int'l is the last thing that I want. If this is enough, I want them to use it. But in our environment, it's recommended to go through this library. So that's why we have those rules. Please.
So there are things that you can use CLDR to imply when you're building the UI. And so I can see the service, have you thought about it, or do you use it to generate standard input masks or things like that? So let's say I'm saying you enter a date free form, you usually use moment or whatever, but you could create an input mask that already has the punctuation pre-populated and only allows you to enter the dates in the right places.
So, I wouldn't say that this is what we wanted from this library. We really wanted to have this support of the patterns of those functionalities. However, the Lightning Web Components is bigger, and it provides you the component, for example, for calendar, for entering numbers or sliders, stuff like this. So in the bigger picture, you can use this. And if you will be using Lightning Web Components, there is a base components package. Those will be tied with this library. So whenever you use base components, you will have this library used under the surface. So you will be pretty sure that if you switch local to Chinese or Arabic, it will all work.
Does the component library, say you're doing an input, like a data input, does it show the skeleton as a placeholder? Or anything like that? So you can have localize, if you're German, you get the date with the periods as the placeholder string, and once you start typing, kind of like a
So again, it's not the task of this library. It's in the higher level, and I don't think it does this, but it could, right? It can read the information that we expose in this library.
And you can expose the patterns, right, through this library?
We can, but actually I have my colleagues from the team here. I think we don't expose the patterns right now.
So I think, the way Lightning Web Component concept is, I can build my own component and do whatever I want, right? Like I can design any custom UI, any custom component that I want. So some of those things can be done, right? Like it's not that this library would do it, but it's like the library is the support of this internationalization through this, right? And using that, if any UI customization or component or anything that the developers want to do, they would do it on that. Okay.
So yeah, I would add to this. We didn't really want to have the Swiss Army knife type of library. We just wanted to address the specific concerns, and those were server-side versus front-end support for patterns. So this is there, and we allow people to build on top of this freely.
So do you have you must have a cache check, so if it's already been loaded up, it's cached, you don't have to do the service call again?
Yes. The object itself is cached. So if you do the formatting once, the next call will go through the cached mechanism. Now, we could go into more details like how this is bundled, because we are using rollup for this, so it's like the per language bundle. So it's not necessarily that if you are on the English UI, you will have the French parsing or Japanese parsing available. You will need to switch to the other bundle. And when the bundle is loaded, it's all there, right? That's why we wanted to have this smallest possible package so the bundle can load as quickly as possible.
What's the name of the bundling again?
Rollup.
Rollup?
Like rollup. It's Webpack for Nano libraries.
Got it.
Yeah.
One more question.
Go ahead.
I noticed that in the parsers, you didn't assign names to the patterns. You left the pattern open, right? So they actually pass an ICU pattern, right?
Yes.
Like there, you have a pattern in your options
Mhm.
object there. I'm just wondering, what was the decision to make the parser take a pattern, whereas the formatter takes a name? You know?
Yeah, so I think this comes down to the size of the packages, because actually we started with supporting the patterns for formatters, but ultimately with the RFP, with the discussion, what really is the requirements, what are the constraints that we have, and the decision was made to use the Int'l directly. So that's why it kind of boils down to that.
Okay.
All right. Thank you very much.
All right, thank you.